Hello and welcome to the industrial part of Chelmsford. We're in Anchor Street and this was where the first iron foundry in Chelmsford moved. It was originally in New Street and it moved up here. A chap called John Brewerley, he set up the first iron foundry here and he was very successful. He passed the company on eventually to his son and his wife, and they made the iron post that fenced off the Chelmsford High Street during the market days. The rope was supplied by Henry Godfrey, who had a factory just down there in Molsham Street. The factory was then taken over later by a chap called Thomas Hungate Dennis, and he was a ironmonger, hydraulics engineer and maker of Victorian heating systems. But his heating systems didn't always work that well, and one of his projects involved heating the Molsham Street St John's Church. Unfortunately, during the process of installation, his men managed to blow up part of the church. But luckily it survived and it's still there today. Thomas Hungate Dennis decided to take on a very clever man with a military background, and that was Rooks Evelyn Bell Crompton, and it was here that they set up their business in the Anchor Iron Works. We're outside Chelmsford Museum, and here we have a Crompton lamp. Now this is a particularly important lamp because it's the only one of its type that still exists, but it is a fine example of Crompton's work, especially regarding public street lighting, and we'll come to that later. But really the story starts with Crompton's brother running an iron foundry in Derbyshire, and he wants to run the iron foundry 24 hours a day. This requires nighttime working. Nighttime working needs lighting, and the lighting that Crompton proposed to his brother was electric street lighting, very new at the time, invented in the early 19th century by Henry Davy, and really taken on by a number of people who were trying to then make it a viable, usable system. The man at the time was a chap called Graham, and he was a Belgian that was living and working in Paris. Crompton went to visit him, and the two of them then came to an agreement about exporting Graham's lighting systems, the dynamos and the arc lamps, to Chelmsford. And this they arranged to do, and Crompton then received the lamps, but very soon he noticed that the quality needed to be improved, so he started to work on it. And with the help of other people within the Crompton organisation, he managed to develop an arc lamp. The principle of the arc lamp is that it's two carbon rods which have a spark between. But as the carbon rods burn with the spark eroding them, they burn at different frequencies. And so there needs to be a controlling mechanism in order to make sure that the spark is maintained. Now Crompton worked out that it was all very well having this set up, but it needed to be in a way that maintained a good spark. Crompton's new improvements to this design placed a controlling mechanism for the carbon rods that made the spark above the light, thereby removing any downward shadows. He also improved the regulation mechanism that controlled the gap between the carbon rods. This reduced flickering and gave steadier light. With all this work, he was greatly helped by a very clever local man called Edmund Pugin, who lived in a large house in Molsham Street called Westbrook. The Crompton Pugin arc lamp design was so successful that it became one of the best arc lamps available at the time, and was later used in a military searchlight in the Boer War. Over the next few years, Crompton took over more and more space in the factory for the production of the electrical lighting equipment. Eventually in 1878, Crompton took over the company from Dennis and founded Crompton and Company. He also renamed the site Anchor Ironworks, later just Arcworks, and they became UK's first electrical engineers. One of the first events to be lit by Crompton was the Henry Regatta in July 1879, when crowds of people gathered at night to see the lighting on the river by the bridge. Then the Butchers' Provident Institution Fete at Waltham Green was lit by 2 Crompton lamps suspended 30 feet above the ground. Next, 50 acres of grounds and lakes at Alexander Palace were lit by 4 Crompton lamps supplied from 4 Graham generators. Around Christmas 1879, Crompton lit his own house in London's Porchester Gardens, using one of his portable generating sets, supplying small arc lamps in the drawing room and the dining room. Back in 1878, Joseph Wilson Swan of Newcastle was credited with being the British inventor of the filament lamp. Mr. Edison took out his broad patent for a similar lamp in America in 1879. Early in the year 1880, a messenger from Messrs. Mawson and Swan, the well-known chemists of Newcastle, to whom Crompton had supplied arc lighting equipment, called on him to say that Mr. Swan urgently desired to see him. He went to Newcastle, where Swan took him to his laboratory and showed him 20 small incandescent lamps, which burned very brightly and steadily, each having a carbon filament enclosed in a globe, exhausted to a nearly perfect vacuum, and claimed that he had solved the problem of electric lighting for internal illumination. Crompton, being impressed by Swan's lamp over his arc lamp, became a director of the Swan United Electric Light Company, maker of Swan lamps. Crompton's company in Chelmsford then manufactured light fittings and generators to supply the Swan Company, and that same year Crompton published one of the first lighting manuals, the Electric Light for Industrial Uses. Later in the same year, 1881, the great physicist Helmut Schultz lectured at University College London, and for the illumination of his experimental work, Crompton supplied him with one of his portable sets of generating plant. For the International Expedition of Electric Lighting held in Paris, autumn of 1881, Crompton sent over a fine exhibit and was awarded the first gold medal ever given for electrical lighting plant. Also in 1881, many important lighting projects followed, including Alexander Palace, Windsor Castle, Holyrood Palace, the new London Law Courts, King's Cross Station, and many other stations and goods yards. These extended into Europe and included the Opera House and several other public buildings in Vienna. Crompton experimented with the effects of arc lighting on vegetation and flowers at Alexander Palace. Sebastian De Ferranti, at the time a student, took great interest in Crompton's research, whilst he was developing his own alternating equipment. A year later, and Crompton installed a mixture of his arc lamps and Swan lamps for the lighting of the Mansion House in London. 1882, and Crompton was made a member of the Society of Telegraph Engineers and sat on a committee to report on rules to be recommended for prevention of fire risks arising from the use of electric light. This society was the forerunner for the Institute of Electrical Engineers, and these people now publish the National Wiring Rules and Regulations. Crompton was keen to promote electrical lighting and cooking for domestic and commercial use. Electric cooking with his assistance was demonstrated in 1885 at a banquet held by the City of London Electric Lighting Company using Crompton equipment. With his success in Vienna in 1886, Crompton looked for a similar opportunity in London with using a generation network, and was introduced to the architect of Kensington Court, a new estate of some 100 houses linked by subways, which allowed the nearly 100 consumers to be supplied from a central generating station without the problem of having to break up public roads. In due course, a 200-volt 3-wire DC electrical distribution system was adopted. Each house was supplied with an underground mains system of bare copper conductors supported on glass in conduits below the pavement, being accessed by removable covers. Crompton had succeeded in building a successful central generating station and distribution network which supplied a whole district on a large scale. He went on to be responsible for many electricity companies, supplying both direct current and alternating current at home and abroad. In 1888, he carried out a successful electrical lighting experiment in Chelmsford. 3 years later, after negotiations with the Borough Council, he agreed to install 218 electrical lamps, including 18 arc lamps in 3 main streets of the town. This innovation made Chelmsford the first town in Great Britain to have public electrical street lighting. The power of all these lamps was supplied by a coal-fired steam engine connected to a turbine housed in the building in Anchor Street in Chelmsford. Also in 1888, Crompton's company issued patents for a galvanometer instrument, and later that year a dynamo electric machine and electric motor. The principle of the dynamo is that if you reverse the operation, you can use it as a motor. 1888 also saw a change in the ownership of the Crompton Company, for it became a limited company and issued shares on the London Stock Exchange. In 1889, Crompton was employing around 600 people at his Anchor Ironworks. His staff called Crompton the Governor. He was very keen to employ ladies because of their ability to reproduce the same process over and over again, with very few errors. Crompton made the first electric toaster, the Eclipse, designed by Alan McMaster in 1893, together with some of the first electrical cookers. He developed many appliances and applications for electrification, such as ceiling fans for warmer climates, specialised items such as electrical furnaces. In 1894, H. Dowsing and E. J. Fox designed a range of electrical appliances for Crompton and his company to manufacture, and these appeared in a catalogue entitled Domestic Electric Machinery, Electrical Heating and Cooking Appliances. These products included electric ovens, kettles, hot plates and a glue pot. This range also had tea urns, electric radiators and an electric frying pan. The source of all the heat for all these appliances was a copper wire element embedded in the enamel of the metal base of the appliance. So we're here in Writtle Road, and in 1896 Crompton had a big fire in the Anchor Street Arc Works and decided to move his premises here. Now this had the advantage that it's a much bigger site, and so he could expand the company. It also is very near to the railway line, which meant that Crompton could bring in raw materials directly into the site, and that meant that he could also take out heavy product as well at the end. This saved on using very powerful expensive road transport. And we can see here that Crompton used a very functional architectural design for his factory, but it still remains today. Colonel Crompton was a self-sufficiently enthusiast and planned to make his new industrial site independent of water and sewerage services. He bored an artesian well further up the hill and used the clay pits, then ponds, as filter beds. The cleaned grey water was then pumped up onto a large high tank ready for reuse. This system functioned until the 1960s, when the site was finally connected to mains water. Under Crompton's leadership, this company carried out work worldwide, mainly in the former British Empire countries, including involvement in India's first Electricity Act, and in 1899 supplying electrical plant for the first generating station in Calcutta. Crompton volunteered for service in the Boer War between 1899 and 1901, and was later promoted to the rank of colonel for his technical work with the army. With the war finished, he worked for the War Office on mechanical transport, and later for the government on making roads suitable for motor traffic. Crompton was also involved in creating precision engineering standards. 1909 saw the first demonstration at the Chelmsford Works of a single-decker electric omnibus driven by a motor developed by the Crompton and Company. This was based on a chassis built by the Motor Omnibus Construction Company based in Walthamstow for trials. Crompton, as ever, was a shrewd businessman and went on to manufacture AC generators as well as DC ones that he had made his name with. 1910, and the Crompton Company produced a range of voltmeters and ammeters. In November 1911, a prototype double-decker battery bus was produced for the omnibus market. The transmission was by two motors and a chain drive to a worm gear acting on the rear wheels. This featured a regenerative braking system and electric valve, which limited the current that was taken from the batteries. This is thought to be the last electric-powered double-decker to be built, until very recently. Although this idea was a success, the company decided that they were not interested in being involved with the mass production of buses, and so the project was immediately discontinued. In 1912, Rooks Evelyn Bell Crompton, the founder of the company, was excluded from the boardroom in a surprise coup. Soon after he left the company, a year later, it was reorganised as a public company under the same name and took over the business of the old company. Then, aged 67 years, he did not retire, but instead concentrated in new interests. Soon after 1914 war broke out, he served on a committee studying the idea of a military fighting tank. After the First World War, the factory continued to grow and prosper, and this gave many local people employment. In 1924, the Electrical Association for Women was founded with the assistance of Colonel Crompton. He wished to develop the domestic use of electricity and saw this organisation as an ideal platform to promote the forming of branches in both the UK and overseas. 1926 saw Colonel Crompton involved in an electricity generating organisation, later become known as the National Grid. In 1928, Crompton and Company Limited became Crompton Parkinson, and this world-famous company served the nation well in World War II. The old Colonel died in 1940, aged 94, but the firm he started expanded to manufacture electric motors, switchgear and electrical instruments, and continued until it was eventually taken over by Hawker Siddeley, and in 1968 operations were transferred away from Chelmsford to Loughborough. We can now, however, remember the old Colonel, as there are many signs of his industrial legacy. We have the fine building in both Writtle Road and also Anchor Street, together with a number of street names in the village, such as Rooks Crescent, Evelyn Place, Crompton Street and Parkinson Drive. The name of Crompton still lives on today, as in the UK we have a Crompton Lamp Company based in Bradford, and in India there is a company producing a large range of domestic appliances called Crompton Consumer Electrics Limited. So here we are in Crompton Street, and this is the side of the factory, but it just shows you how really well built it was, and Crompton obviously meant the company to last a long time. Now he was very keen to get involved with he was very keen for ladies to be working for him. He saw that their dexterity and their ability to reproduce without very few errors processes that were quite complicated was very important, and so he employed a lot of ladies. He also liked to train his staff, and so he set up an apprenticeship scheme. 5 years his apprenticeship scheme ran, and it included both theory and very much practical and hands-on work. One of his first apprentices was a chap called Frank Christie, and because he was trained by Crompton, he really understood the electrical industry. And later he set a company up with his brother, and they formed the Christie Company, which became electrical contractors throughout the country. Now, Crompton not only really liked to look after his workers, he also decided to build houses to house them. And so in this street, in Crompton Street, there are a larger number of terrace houses that were built the same time as the factory. Now, this today is part of a housing estate, but we have Crompton Street, we have Rooks Crescent, and we have even a street called Cromer, which is a combination of Crompton and Marconi. So very much the Crompton legacy lives on. Thank you for listening.